Good morning, good evening, good afternoon, and welcome back to another math lesson. Today we are going to be moving on to lesson number 2, where we will be talking about reflecting graphs of functions. Okay, so let's get started. A reflection of a graph creates a mirror image in a line called the line of reflection. A reflection does not change the shape of the graph, but it may change the orientation of it. Okay, so for a function, we're given for a function y equals f of x. Okay, it's a vertical reflection. Okay, so that's y is equal to, and I'm going to highlight this. Okay, negative f of x. Okay, is the graph of y equals f of x after a reflection about and over, okay, the x-axis. Okay, so when you see any function that has a negative out in front, like a negative a value, for example, okay, this entire function is going to be flipped over the x-axis. Okay, so the horizontal axis is going to be flipped over top of it. Okay, so note any point. So the point xy from the original function becomes the image point x negative y. Okay, so it's been flipped. Okay, so your x values remain the same. Okay, but your y values are going to change. Okay, so in a vertical reflection, the x-intercepts, okay, are the invariant points. So those are the points that are going to remain the same, okay, because your x values don't change. Okay, it's just going to be your y values. Okay, so that just means all your positive y values becomes negative y values, and all your negative y values become your positive y values. Okay, so that is a vertical reflection, which brings us now to a horizontal reflection. A horizontal reflection, so that's y is equal to f of negative x. Okay, so remember the negative is now inside or next to x. Okay, so is the graph of y equals f of x after a reflection about, in, over, and in this case it's going to be the y-axis. Okay, so in this case now all your y values will remain the same. Okay, so it's going to flip over the vertical axis. This is going to go left and right. Okay, so the original point xy for the original function f of x becomes the image point now of negative x and positive y. Okay, and lastly, in a horizontal reflection, the y-intercepts. Okay, so the y-intercepts, wherever it crosses the y-axis, okay, are the invariant points. And again, a reminder, the invariant points is the same regardless of the transformation that has happened. Okay, let's try example number 1, where we're going to draw the graph resulting from the following transformations and identify the invariant point. Okay, so what we're going to do is we're going to do the transformations of these two. Okay, so we have y is equal to negative f of x. This is going to be a vertical. Okay, so this is going to be a vertical transformation. Or sorry, a vertical reflection. Let's use the words. A vertical reflection. Okay, so we're going to go about this, and it's going to be flipped over the x-axis. So yeah, it's interesting because whenever time we think about x values, that's the horizontal part, right? But when it's a vertical reflection, you're going to flip over the x-axis. Okay, so in these particular points here, only the y values will change. Okay, your x values will remain the same. Okay, so this first point, okay, it's actually going to reflect it over the x-axis, so it's going to be moved down. Instead of y is equal at 1, it's going to be y is negative 1. Instead of y being at 3, so this is 1, 2, 3, it's going to be y is equal to negative 3. Okay, so it's going to end up down here. When y is 0, x is also 0, so I'm just going to draw a point there, okay? That's also our invariant point because this crosses the x-axis, okay? We have x is equal to, y is equal to negative 3, so we're going to have y is equal to positive 3 here, and then we have y is equal to negative 2, so we're going to end it off at y is equal to positive 2. And we can go ahead and connect these points, like so. There. Those are all your points after they've been reflected vertically. Okay, so the last bit there was identify the invariant point. So again, from x to y, we've done the flip. So now it's x and negative y. So the invariant point in this case is wherever this graph crosses the x-axis. Okay, so negative 2 and 0 is the invariant point. Moving on to part B. Okay, so part B says y is equal to f of negative x. Okay, so this is going to be a horizontal reflection. Okay, so it's going to be a reflection over the y-axis. Okay, so it's going to be over the y-axis. This is going to be your horizontal reflection. So, okay, that means all your positive x's become negative x's, and all your negative x's become positive x's. Your y values are going to remain the same. Okay, so let's try some here. We have, this is x equal to, this is negative 1, 2, 3, 4. So this is 4, right? 1, 2, 3, 4, 5. Ooh, 5. Okay, so this is now going to be x is equal to 5. So 1, 2, 3, 4, 5. Okay, this is at x is equal to 1, 2, 3. So now instead of it being at negative 3, it's going to be a positive 3. And this is at positive 3, so now it's going to be at negative 3. Okay, and it's going to cross the y-axis at this point. Okay, so we're just going to connect the dots. So notice how it is an exact mirror image, okay, of the previous function, right? It looks the exact same. It's just been flipped over the y-axis. Okay, it looks the exact same. So the invariant point, again, it's going to be x, y is your original, but now it's going to be negative x and positive y in this case. Okay, so that means in this case, it's going to be the y-intercept where it's going to remain the same. So it's going to be 0 and, well, let's see, 2, 3, 4, 5, 6, 7, 8, 9. So 0, 9 is the invariant point. All right, so that's how you would do a vertical reflection and a horizontal reflection. Moving on to example number 2, we have given f of x is equal to x minus 3 to the power of 2. We're going to graph the following. So we're going to graph the negative f of x. So this, again, is going to be a vertical. Okay, this is going to be a vertical reflection. Okay, so this is going to be a vertical reflection. So we're going to reflect it over the x the x-axis, okay? So what we're going to do is we're going to just kind of remember what the original function is. So the original function, without any translations, okay, is x squared. So if we can recall what x squared is, right? So if we can recall what the shape of the function of x squared is, then it'll be easier for us to figure out what the translations have been. Okay, so we have y is equal to x squared, so that's like negative 2, 4, negative 1, 1, right? 0, 0. This is 1 and 1, and 2 and 4. These are like the main points to graph a quadratic function, okay? But what we're going to do is we're going to use the mapping notation to kind of move things around, okay? So in this particular function, okay, what has happened is we've actually shifted this graph 3 units to the right. Okay, so we're going to go x plus 3. Okay, and then what's happened is we have a vertical reflection. So that's actually going to change our y's. So we're going to put a negative y there. Okay, so now it's all this does is it's shifted over. We're going to shift it over to the right. So all of our x values, we're going to add 3 to it. So instead of it being now at negative 2 and 4, well, we're going to add 3 to it. So now this is negative 2 plus 3. Well, that gives us 1. And instead of it being at 4, it's now at negative 4. So it just switches. Okay. We have x is equal to negative 1, add 3, that just gives us a 2. Okay, 2 and negative 1, add 3, you get 3 and 0. So those remain the same. So, right, so we have our invariant point there, right? Crosses the x-axis at that point, so it's going to be the same. Okay, we have 1 and 1, but that changes now so that it's 4 and negative 1. And the last one we have is at 5 and we're going to minus that, so it's going to be negative 4. Okay, so let's go ahead and let's plot these points and see what we come up with. Okay, so we've gone ahead and we've plotted these points out. Okay, so here we have 1 and negative 4, 2 and negative 1, 3, 0, 4 and 1, and 5 and negative 4. Okay, so we've plotted out our points, which means all that it looks like it's going to be a parabola that's opening down, which makes sense because the original function, oops, let's try that again. Because the original function, okay, has no negative value in front of the x. And because it doesn't, that original graph should open up. Okay, but because now we've done a vertical reflection, this new graph that's been transformed or translated is now opening down. Okay, so that is how you would do a vertical reflection for this particular function. Okay, moving on to part B, we have f of negative x. So this is going to be a horizontal reflection. Okay, so this is going to be a horizontal reflection. Okay, so because of that, our x's are going to change. Okay, now we know what the excuse me, we know what the original numbers were. So let's go ahead and let's fill those back in real quick. Okay, so let's go ahead and let's apply the transformations to it. Okay, so the transformation is we're going to multiply everything by -1 for our x values, but our y values are going to remain the same. Okay, so in this first one, we have -2. We're going to add 3 to it, which brings us to +1, but then we got to multiply it by -1 to do the reflection as well. So it's going to be -1 and 4. Okay, next one we have -1 plus 3, which brings us to -2. Multiply that by -1, so we have -2 and 1. We have 0, 0, so we're going to add 3 to it. So that 3, that's going to bring us now to +3, but then we're going to multiply by -1, which brings us to -3 and 0. And then nextly we have 1 plus 3, which is 4. Multiply that by -1. We have -4 and 1. And then finally, the last bit, we have 2 plus 3, which brings us to 5. Multiply that by -1, which brings us now to -5 and 4. Okay, so again, you may be wondering, well, why are we adding it first before we do the reflection? Remember in this case that the original function, okay, told us to to add 3 first, and then now after we've done that, then we apply the reflection to it. Okay, so let's go ahead and let's plot these points out. Okay, so now that we've gone ahead and plotted these points out, we can now graph this function. Okay, so it's going to be coming down. It's still going to open up because our y values have not changed. Okay, so you know what? I'll add these points in again so that we can see them. Okay, so there they are right there. Okay, so again, this graph has been reflected over the y-axis because originally this graph should be, the vertex for this particular graph should be in quadrant number 1. Okay, so it should be in the top right corner. Okay, it shouldn't be there, but because we've multiplied all their x values by -1, right, to do the horizontal reflection, that's why the vertex is no longer in quadrant 1, it's in quadrant number 2. Okay, but that's how you would do an example of horizontal reflections for these particular functions. Well, that is it for today's lesson on horizontal and vertical reflections. I hope you enjoyed it. Remember, when it comes to math, keep calm and show your work.